Hi there, it's Professor Monte. We're talking about the principle of square roots. So essentially, the principle of square roots says this. If x squared equals n, then x, which is the square root of x squared, is going to be negative square root of n or positive square root of n. And often we just write it as plus or minus the square root of n. Okay, and the question may be, well, why is that the case? Well, think about this. If I have x squared equals n, and I want to solve that, well, what I'm going to do is I'm going to take the square root of both sides. Now, we often just say the square root of x squared is just x because we're assuming that x is a positive number. But in actuality, the square root of x squared is the absolute value of x. That's what we first learned when we talked about this property. And so I've got that equals the square root of n. Well, remember, I don't know if what was in here was positive or negative before it came out of the square root. So from this property, we'd say, oh, x is either negative root n or x is positive root n. And that's what the square root properties say. And so it's really easy to apply. I've got a couple examples up there. So the first one, x squared equals 5. What we do, let me rewrite that so we see the original problem, is to get rid of the square, I'm going to take the square root of both sides. And this property essentially says I can take the square root of both sides as long as I just remember to say plus or minus on one side. And so now I don't have to say the absolute value. I've kind of skipped this step. I just say x equals plus or minus the square root of 5, and I'm done. I get two answers. Remember, that means x equals negative square root of 5 or x equals positive square root of 5. Just the same way we have this written as the property. Okay, let's look at another one. This time, we've got a square. We have a quadratic equation, but we have an x squared, but we don't have an x term. If that's ever the case, what I'm going to do is I'm just going to isolate the x squared, take the square root of both sides, use the property. So let's add 3 to both sides. So I've got 2x equals 32. Oh, 2x squared equals 32. Divide both sides by 2, x squared equals 16, and now I can take the square root of both sides as long as I put the plus or minus there. And so now I get x equals plus or minus 4, and it gives me two answers, 4 or negative 4. Your instructor may want you to write it similar to how we did here. Oh, x equals negative 4 or x equals 4. Or put it in the braces, negative 4 and 4. However they want you to write the answer, make sure you write the answer that way. I accept x equals plus or minus 4, and we can check. If I plug it 4 in there, 4 squared is 16, times 2 is 32, minus 3 is 29, it checks. If I plug the minus 4, it still works because negative 4 squared is positive 16, times 2 is 32, minus 3 is 29. So unlike when we're squaring both sides, we have to check the solutions to find out if there's an extraneous solution. This won't give me extraneous solutions. If it's wrong, it means I made a mistake. But the key here is if you put the square root on both sides, you have to say plus or minus. You don't have to do that with cubed roots, but you have to do those square roots. Now, if it just says the square root of 16, for instance, if it doesn't say plus or minus in front of it, they're just asking for the primary root. They just want the 4. But if you take the square root of both sides, remember to say plus or minus, it's going to give you two answers, unless, of course, you have the square root of 0, which you just get one answer. Or if it's the square root of negative, we'll see that in a later time. It's a complex number. Okay, but remember that property. If you take the square root of both sides, just remember to say plus or minus so you don't lose potentially one of your answers.